This is a videotape made during test runs in August 1985 of a WindJammer soft airfoil turbine in the Altamont Pass area of California. The basic concept is old, one of the oldest known to Western man. Windmills using sails or soft airfoils originated in the Greek islands several thousand years ago, and they continue to supply power there. More than 10,000 are presently in use for irrigation purposes on the Lassithi Plain in Crete. What has been done is to combine this concept with 20th century technology. The result is a cost-effective, easily understood, maintained, and repaired turbine, which, because of its very large capture area, is especially adapted to the low and medium wind regimes which dominate in most areas of the world. As these photos make clear, it is slow turning, safe, quiet, and also very beautiful. Whatever their considerable environmental advantages, wind turbines must be cost competitive with existing conventional hydro and thermal technologies if they are to play a continuing role in power generation. The WindJammer is cost effective. We project an installed cost per kilowatt hour of somewhere around 2.7 cents, which is competitive with any existing technology. The WindJammer, moreover, is an especially appropriate technology. Its operation is easily explained. The sails are furled or unfurled depending on the speed of the wind. When the sails are fully extended, very little wind is needed to bring the turbine up to operating speed. At high wind velocities, the sails can be furled completely. This fact, together with a sequence of generators of different sizes, makes possible a complete or closed power curve. Power is generated continuously over the whole wind spectrum. These pictures were taken, as you can see on the screen from time to time, in wind speeds of between 7 and 15 miles per hour. The rim of the turbine rests on standard truck tires, which it turns at an obvious and considerable mechanical advantage. The tires, in turn, are attached to induction generators. The rim, moving at constant speed, turns the tires which drive the generators. In addition to the furling of the sails, there are also brakes to be employed in very high wind velocities. The generators, brakes, and sail furling mechanisms are all at eye level and easy to reach and work on. All of them, as well as the sail material, are off the shelf, available, inexpensive, and relatively easy to repair. There are no lathed or complex components on this turbine. The design philosophy from the outset has been to build something that can be understood, and if a part on it breaks, can be fixed without great difficulty or cost. In the United States in the early 1930s, windmills supplied about 10% of total electricity requirements, only slightly less than nuclear power does today. The machines used were simple, they were comprehensible, and the average person could repair them. This was the basis of their success. Extensive performance testing of the WindJammer you see here has been carried out using state-of-the-art equipment monitored by skilled professionals. It confirms all of our projections. With the sails only 75% deployed, for example, we were able to reach 90% of the rated output of 100 kilowatts at 25 miles per hour. The evolution of the WindJammer design has taken place over the last 10 years. Prototypes conforming to the original designs of Greg Cook, at one time Dean of the Illinois Institute of Technology, were installed and tested first at Antioch, Illinois, and then at Livingston, Montana. The Altamont machine you see is the third in a series.
A fourth prototype has been in a rigorous testing program since February of 1989. The design philosophy remains the same. It continues to employ the high solidity, low RPM, high torque concepts embodied in the windmills long familiar across the Great Plains. The WindJammer IV allowed us to try out a number of modifications, including an upwind configuration, a carriage that rests on cantilever trusses, the elimination of cables, and sail furling motors placed at the ends of the spindles, rather than in the central hub. Some of these modifications, and others that have resulted from a thorough review of the design, will be incorporated into the first of our commercial models, the WindJammer V. Perhaps most important, the WindJammer IV prototype has confirmed our earlier data demonstrating that we can produce more power at lower wind speeds than conventional propeller-driven turbines. This, very briefly and without technical detail, is the story. An old idea proven over thousands of years, adapted to the cost-effective production of electricity in the 20th century. Our turbine is safe, quiet, and beautiful. It should have the high capacity and reliability factors that utilities need and be able to enter the low and medium wind regime markets that other turbines cannot, markets that dominate here and around the world. To illustrate the evolution of design which we pursued, let us show you some still pictures. First, the WindJammer II, erected in Livingston, Montana. To give you a feel for size, this picture illustrates workmen mounting a sail on that machine. Next, another view of WindJammer III spinning in Altamont. Finally, two pictures of the WindJammer IV, an upwind cantilevered prototype. We are in the process of raising the funds needed to construct and erect a demonstration project in California. National concern over acid rain and a global warming trend, effects of the use of fossil fuels to produce electrical energy, are placing renewed emphasis on wind technology. The WindJammer represents an important breakthrough in the field of alternate energy.